Welcome to qnawire.
In this case, we have two speakers that are in a plane that are 5 meters apart from each other. I'm going to consider this position as being the zero, so the distance over here is going to be 2.5 meters, and to the left, 2.5 meters, each of them. And we have an observer that is at a distance equal to 12 meters from the center of each of them. So what we know is that both of the speakers are in phase and they're reproducing a sound with the same frequency. Now what happens is that the observer is going to move into a position that is directly in front of one of the speakers, but still 12 meters away. So we're going to have the following triangle. Here we're going to have 12 meters, and over here we're going to have a different distance. Down here we have 5 meters, so we can find the difference on the path. In this case, since we're dealing with destructive interference, what we know is that the difference of the path, or the difference of the length that each of the sound sources are going to travel, needs to be equal to n times lambda over 2, a half number of the wavelengths that we consider. So now what we're going to get is the path difference in between each of them. So for doing that, we need to calculate this distance x. So x is going to be equal to square root of 12 squared plus 5 squared. Directly, x is equal to 13 meters. Now, with this, what we get is that the change of length is equal to 1 meter. And this needs to be equal to n times lambda divided by 2. So from here, we get that lambda can be equal to 2 times 1 meter divided by n. And at the same time, we know that the frequency is going to be equal to the speed of sound divided by lambda. So the possible frequencies that we can get are going to be equal to the speed of sound, which is 343 meters per second, divided by 2 meters, and multiply this by n. So the lowest possible frequency is going to correspond is going to be equal for n equals 1. So the lowest possible frequency that we're going to be able to hear over here corresponds to 343 divided by 2, which is 171.5 hertz. And we want to know what are the other possible frequencies between 100 and 1000 hertz. So in order to do that, what we need is to multiply the values for n that we got in our equation. So this would be for n equal 2, for n equal 3, for n equal 4, and so on. And we're going to select the ones that correspond to the range. N equal 5 and following. For n equal 2, we're going to get 343 meters per second. For 343 hertz in this case. Sorry about that. For n equal 3, what we're going to get is 514.5 hertz. For n equal 4 corresponds 686 hertz. N equal 5 gives us 857.5 hertz. And n equals 6 is going to give 1029 hertz. So the possible frequencies in between 100 and 1000 hertz are the following. And the lowest one, which is the answer for question 1, is 171.5 hertz. This corresponds to n equal 1. So with that, it would be all. Thank you very much and have a good one.